Hi, my name is Abby.
Hi, my name is Arthi, and we're from the Mississauga Library.
Have you ever wondered why the lights in our homes turn on whenever you click the switch? Or how about our appliances? Why do they go on and off? It's because of something called electricity.
Electricity is all around us, in our cars, in our homes, our schools. It travels in a circular loop called a circuit, and circuit has three parts: an energy source, an energy pathway for the energy to flow through, as well as an energy receiver.
Ta-da! Here we have a very simple drawing of a circuit with an energy receiver, such as a bulb, and a energy source, such as a battery, and the lines around it are the pathway for the energy to flow to the receiver. And what better way to find out how circuits work than by making our very own lightsaber?
Here's what you'll need: cardstock paper, 2 different colored LED lights. We chose one red LED and one green LED. You can test that they work by connecting them to a battery. 1 circular battery, 3 1-inch brad fasteners. Test out that your brad fasteners can conduct energy before you use them. Metal paper clips. Test that your paper clips can conduct energy. Markers. 1 white or clear straw cut into 2 smaller pieces. Scissors and tape. First, draw a character like Darth Vader onto the cardstock paper. Or if you'd like, you can also make an origami and tape it down onto the cardstock paper.
Draw in the lightsaber hilts to the left and right of his body. Make sure the width is about the same as the width of the straw.
Before we insert the LED lights, test the red and green LED lights to see which of the 2 prongs are positive and negative. For our LED lights, the longer prong is the positive side.
Next, poke a small line through the top part of the lightsaber with one of the ends of your brad fasteners. Then insert the red LED light prongs through the right lightsaber insert. Fold down the positive prong to the right side, then fold down the negative prong to the left side. After, flip the cardstock to the back side and position the red LED light so that it is bent flat on its side.
Repeat this with the green LED, except this time, the positive prong will be on the left side and the negative prong will be on the right side. After, flip the cardstock to the back side and position the green LED light so that it is bent flat on its side.
Next, on the back side of your cardstock, place the battery somewhere around where Darth Vader's head would be. Then, trace the battery's outline.
Now let's make the switch that turns on the LED lights. Take 1 brad fastener and poke it through the front of the cardstock paper. Fold down on the prongs, 1 on the left side and 1 on the right side.
Place a paper clip around the brad fastener. This paper clip will act as the switch that closes the electric circuit. Measure out the distance to the end of the paper clip when it is pointing to the southeast, and then mark this position with a pencil. Do the same thing when the paper clip is pointing to the southwest of the brad fastener.
Next, take another brad fastener and poke it through the southeast mark you just made, and press down the 2 prongs to the left on the back side of the cardstock paper. Do the same thing to the southwest mark. Then press the 2 prongs down to the right on the back side of the cardstock paper.
Now that you have 2 of the 3 things you need for a complete circuit in place, energy source is the battery, energy receiver are the LED lights, we just need to add the energy pathway using the metal brad fasteners and the metal paper clips. If it's easier, you can draw out a pathway for your paper clips first.
Stretch 2 paper clips and make them straight. Use these 2 wires to connect the left and right prongs of the middle brad fastener to the negative side of the battery. Tape down the battery.
Next, connect the positive left prong of the green LED light to the positive side of the battery using a paper clip. Stretch out the paper clip if you need to. Then connect the negative right prong of the green LED light to the brad fastener on the right.
Repeat this step with the red LED light. Connect the positive prong, right, of the red LED light to the positive side of the battery using the paper clip. Connect the negative prong, left, to the brad fastener on the left. Tape the paper clips down if you need to, but make sure that there is no tape between any of the metal parts that could disrupt the flow of electrons or energy.
And finally, cover the LED lights with a short straw of the color of your choice.
There you have it! To test out your circuit, you can toggle the paperclip on the front of your cardstock paper going left or right. If the light lights up, then you're good to go. Now the question is, which side are you going to choose?
You may wonder why we used metal paper clips instead of the plastic kind. This is because metals are considered conductors, and conductors are materials and objects that allow energy to flow in one or more directions. Materials such as silver, aluminum, copper, and steel are really great conductors.
But did you know that water and lemon juice are also conductors? Amazing!
Then we have materials that stop the flow of electricity, and these materials are called insulators. Some of the more common ones are oil, plastic, rubber, and wood. Today, in our experiment, if we had used plastic paper clips, we wouldn't have been able to awaken the force.
So that's about it. Before you sign off, please remember to subscribe to our YouTube channel, as well as check out our library website and social media platforms.
Thanks, and
see you next
time.